Hi everyone, this is your math guru. In this video, I'm going to show you how to find the perimeter of the rectangle ABCF using trigonometric ratios and identities. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. In the diagram, rectangle ABCF is inscribed in a semicircle with center O. The radius of the semicircle is 8 centimeters. Angle BOC is 2 theta. If the perimeter of the rectangle ABCF is represented by P, we have to show that P equals 16 cos theta plus 32 sine theta. If you go back to the diagram, we've been told that the rectangle is inscribed in a semicircle, and therefore, if you look at triangle BOC as shown, that will be an isosceles triangle because OC is the radius of a circle, so therefore OC and OP are equal. They're both radii. So stating that quickly, I have triangle BOC is isosceles. Therefore, base angles of an isosceles triangle are equal, so angle OBC is equal to angle OCB. I'm going to call that alpha. So let me tag that in the diagram. This alpha, and this is also alpha. So therefore, using the properties of the sum of angles in a triangle, I have alpha plus 2 theta equals 180 degrees. The sum of angles in a triangle. So therefore, 2 alpha plus 2 theta equals 180 degrees. If I factor out 2, I have dividing each term by 2, and whatever you do on your left, you do on your right. What I'm going to have is alpha plus theta equals 90 degrees. So therefore, making alpha the subject of formula, alpha equals 90 degrees minus theta. So that's the value I'm going to use for my alpha. So therefore, I can state that angle OCB is equal to angle COF, which is equal to 90 degrees minus theta. So what I've done is, because ABCF is a rectangle, we know that opposite sides of a rectangle are parallel and equal. So therefore, this angle, as shown, is equal to this angle. That's alternate angles. So that's alternate angles are equal. Therefore, using the triangle COF, I'm going to draw that out here. I have C, O, and F. Remember, OC is my radii, so that's 8 centimeters. I have this angle, that's 90 minus theta. To find the distance OF, using my trig ratios, the side facing the angle or the reference angle is the opposite. The longest side is your hypotenuse and the last side is your adjacent. So because I'm trying to look for my adjacent and I have my hypotenuse, I have cos theta, or cos of the reference angle, equals adjacent over hypotenuse. So the reference angle, cos 90 degrees minus theta, equals my adjacent, that's OF, over hypotenuse, 8 centimeters. So therefore, using the cofunction, I have cos 90 degree minus theta equals sine theta. That's cofunction identity. So therefore I have sine theta equals OF over 8, and this is over 1. If I cross multiply, I have the distance OF equals 8 sine theta. And note that from the diagram, the distance OF is the same thing as the distance OE, because triangles OBE and OCF are the same. So therefore, to find the total distance, EF is equal to 2 times, I'm going to break that down, it's OE plus OF, and that is 8 sine theta plus 8 sine theta. Therefore, the distance EF, which serves as one of the sides of the rectangle, will be 16 sine theta. So we've been able to find the length of the rectangle. The next step is to find the breadth or the width of the rectangle. So using trigonometric ratios, the distance OC, that's the hypotenuse, so I have OC squared is equal to OF squared plus CF squared. That's your Pythagoras theorem, not your trig ratios. So I have that as Pythagoras theorem. OC from the diagram is 8 centimeters, so I have 8 squared equals OF, that's 8 sine theta all squared, plus CF squared. I have 64 equals 64 sine squared theta plus CF squared, making CF the subject of formula. I have CF squared equals 64 minus 64 sine squared theta. If I factor out 64 as a common factor, I have 1 minus sine squared theta. Note that this is an identity, a trig identity, because cos squared theta plus sine squared theta equals to 1. So therefore, cos squared theta equals 1 minus sine squared theta. So I'm going to change that. I have CF squared equals 64. That changes to cos squared theta. So therefore, finding the square root of both sides, I have the distance CF, which is the width of the rectangle, equals 8 cos theta. So therefore, to find the perimeter P, note that the perimeter is the total distance round the outside of an object. So therefore, perimeter P equals the distance BC plus CF plus EF plus BE. That will be BC. Remember, opposite sides of a rectangle are equal, so it's 16 sine theta plus CF, it's cos theta, plus BE, that's 8 cos theta, plus BC, that's BE, and EF, I have one more side, 16 sine theta. Therefore, the perimeter P equals 8 cos theta plus 8 cos theta, that's 16 cos theta, plus 16 sine theta plus 16 sine theta, that's 32 sine theta. So note that we've been able to show that P equals 16 cos theta plus 32 sine theta. Thanks for watching. Bye.